everyone and all of you. I'm so happy to see that you are joining us for the Marconi Society's Decade of Digital Inclusion event series. Today, we are going to have our second virtual track as part of our 6G Summit on Connecting the Unconnected. For those of you who might be meeting us for the first time, the Marconi Society is a nonprofit dedicated to ensuring that the opportunities of the network are available to everyone on the planet. I'm the Marconi Society's Executive Director, Samantha Erkmen. Our chair is Vint Cerf, one of the creators of the internet and a leading visionary of our time. The event series that you're joining today brings together leaders in technology, policy, and digital inclusion. Our goal here is to create conversations and collaborations that will help bring the un- and underconnected online in a way that is accessible, affordable, safe, and engaging. So we're proud and honored to have some really great and incredible sponsors for this event who are as dedicated as we are to ensuring digital inclusion. I would particularly like to acknowledge our top sponsors, Cisco, Crown Castle, and Sigrid and Vint Cerf. Thank you so much for that support. But that's not all. These organizations and people on this slide have supported our event in so many ways. The breadth of our sponsors is one of the best testaments to the interdisciplinary nature of this event and the opportunity that we will address. Finally, I want to just add one more special thank you to the Internet Society for being our streaming partner for this series and allowing and enabling those of you who are joining us through YouTube and other platforms to join us at no charge. But through the generosity of our sponsors, we've also been allowed to offer some ticket prices for our entire 6-week event series that features over 75 experts for only $49 for the general public and $25 for students. So if you've not already registered and you are interested in seeing what else we have to provide, please do so today. So now I'm going to turn the session over to Anna García Armada to kick off the session. Thank you so much.
Thank you very much, Samantha. Thank you to Marconi Society and to Professor Slim for inviting me to chair this panel. It is a real pleasure. I'm going to share my screen so we can see a couple of slides and to start the discussion. So first of all, let me introduce myself. My name is Ana García Armada. I am a professor at Universidad Carlos III de Madrid. It is a university in Madrid, Spain. And I am a researcher in the area of signal processing for wireless communications. I do quite theoretical work, but I also have the pleasure to have some nice projects with several operators and manufacturers. And I would like to show you just an example of this photo of a very nice lady watching live, being immersed in a scene of her times when she was young. And this is an example of how connecting the unconnected, and this is not just about giving them the possibility to connect, but also the means and the knowledge, we can improve our lives and the lives of everybody. This is the topic of our panel today. It is about providing connectivity. We know we are going to see many advances in the next years about wireless communications, be them by satellite or terrestrial, by traditional radio frequency or by optical wireless. All of them are going to provide unprecedented changes in terms of high speed, low latency, and ubiquitous coverage. But of course, in order to succeed connecting the unconnected, they are also going to face the need of many technological breakthroughs and hurdles to be overcome. There are business models and economics, and there are the needs to provide new services to many people. And to talk about this, we couldn't have better experts than those we have today with us. We have Anton, Vice President of ViaSat. We have Ruth Pritchard-Kelly, Senior Advisor of OneWeb. We have Choi, Founder and Chairman of Curvanet. And we have Baris, Erkmen, Free Space Optical Communications Lead of X, formerly Google X. So the plan today is first, they are going to do a presentation about what are their views regarding their technologies and regarding connected, the unconnected. And then we will have the time for questions. So please feel free to anytime write questions in the chat. We will be looking at them and we will be answering later. And without any further delay, I'm going to just again share my screen so we can have the screen of the first speaker, who's going to be Anton Monk. So Anton, you may start sharing while I introduce you. So Anton Monk is Vice President and CTO of Wireless Initiatives at ViaSat. And this is a global provider of high-speed satellite broadband services and secure networking service systems. He was also the Vice President of Technology Strategy, Business Development and Partnerships at XCOM Labs, which develops innovative wireless technologies in new 5G verticals. And previously, he was the VP of Strategic Alliances and Standards at Cohere Technologies, just to name a few. So you see, we are here in the hands of experts. And please, Anton, go ahead and let us know what is your view.
Thank you, Anna. Hopefully everybody can see full screen, the usual check that we have to do. Thanks for the invitation. It's a pleasure to be here. And this is a topic that's near and dear to my heart and to us at ViaSat. We will be soon, I'll talk a little bit more about our current plans, launching a global constellation of GEO satellites. We have a few different companies represented here, from LEO through GEO. And one of the most critical areas that I work on is bringing connectivity through various access techniques to remote areas of the world, areas like in Mexico, Brazil, Guatemala, Nigeria, DRC, Namibia. And I'll talk about, first of all, what it is that we do, and then second of all, what some of the really difficult challenges are, and then maybe really what the connection is to 6G. Because I think at this point, nobody really knows what 6G is, but I think our goal is to try to figure out where the gaps are. We went from 4G to 5G, now people are talking about 6G. What does that really have to do with digital inclusion? Okay, let's see here. Oops, there we go. So here's some of the, here are some of the things that ViaSat is involved in. You can see many of them have to do with bringing connectivity to rural areas. We do home and business internet in unserved locations, underserved locations. We do enterprise services in remote locations. We actually have the largest overseas LTE microwave network in the world over the Gulf of Mexico. We provide high-speed in-flight connectivity to airplanes. I guess you could call that remote. Used to be unconnected locations, maritime. And I think most importantly for this topic, a lot of efforts around the world in rural cellular and Wi-Fi solutions with a satellite backhaul. We also have a large government and defense business, but I won't be talking about that. So I think one of the most critical things for these areas that we're talking about, rural connectivity and the unconnected, is the cost. You can talk about 3G, 4G, 5G, 6G, but if you can't bring the costs down to support average revenues per user, ARPUs, in the $1.50 to $4 range, which is unheard of in the Western world, you won't have a business. If you don't have a business, then it's not going to work for any of the parties involved. And so you can see here some of the advancements that have happened over the past 10 years or so. The ones in blue are ours. You can see the leapfrogging effect as companies keep leading the charge. And this is a critical component of reducing cost So over the past years, we've led the charge in going from a gigabit per second to our next generation GEO satellites, ViaSat 3, which will provide over a terabit per second per satellite. That's not enough alone. Costs have to come down because one of the most challenging areas in bringing rural connectivity over satellite is satellite capacity costs. And so over the same period, there's been a 400 times cost reduction in price per megabit per second. Skip ahead a little bit. We're already planning our next generation GEO satellites, ViaSat 4, the ViaSat 4 constellation. Those will provide over 5 terabits per second per satellite. These are some of the satellites that we have up in space right now. You'll see ViaSat 3 is planning to launch in the first half of next year. And a little bit more about that. It is a global constellation. First one will cover the US and North America, South America. Next one is EMEA and Africa. And then the third one launched about, each one with about 6 months to a year between them will be launched above Asia Pacific region. Okay, so what I want to do quickly now is play a video. It's easy for us to talk about the unconnected, but there's nothing like actually seeing what's involved and who are the people that we're talking about bringing connectivity to. So I'll talk about, this is a short video of what we've done, some of the work we've done in Mexico. And hopefully this, I think I needed to stop sharing the other one. This will work.
In Mexico, just outside of bustling city centers, there are millions of people with no reliable internet connection.
¿Tienes internet aquí?
No.
Nunca nos han apoyado aquí con internet.
At ViaSat, we're working to bring fast, reliable, affordable internet to these remote towns. Since launch, ViaSat Community Internet Service in Mexico has reached more than 1.8 million people, with hotspots installed in all of Mexico's 32 states.
Ya vamos progresando, ya van a poder hacer más negocio por internet. Algún mandado o alguna urgencia, un mensaje, y ya está la respuesta al instante. Ahorita con esto del internet, gracias a Dios, que la respuesta es rápida.
Community internet in Mexico was just the beginning. In 2019, we expanded.
So that was a couple years old. I'll do one more quick one. This is in Nigeria.
Nigeria ranks 4th in the world for the highest number of people without internet. Many without access live outside city centers, where connectivity is harder to come by due to lack of infrastructure and regulatory challenges.
Most of the network providers have not really penetrated this place.
I don't like network or internet communicates yet.
In 2021, we took the first step to connecting Africa, starting with Nigeria.
Coming of ViaSat, I think, is a blessing. ViaSat gave us that fast connection.
It will help us to do our assignments, it will help us to do online business, and it will help us improve our life.
We've already connected thousands in Nigeria, which means more education, business, and opportunity throughout the area. And after we launch our ViaSat 3 satellites, we'll be able to extend connectivity to all of Africa and the world. That is something to celebrate. ViaSat, on the way to becoming the world's first truly global internet service provider.
Okay, so that wasn't meant to be an advertisement, but that's how our marketing group puts these together. I really wanted to show what it's like. Let me go back to my presentation. Second. Okay, I want to go back to my presentation because I want to talk about what it means to bring connectivity to these people. I was lucky enough to actually go down and visit some of our sites in Guatemala to give you a sense for how remote these areas are. It took about 4 hours to drive out to these villages, and there's really very little there. Incredible amounts of vegetation. Connectivity is really not present unless somebody is willing to bring satellite connectivity. There's no way to connect microwave. It's too far from any fiber. But again, unless you have the key components, which are often not technical or technology related, you have to have a business model that makes sense to all of us. There's not really going to be a way to provide this connectivity. So I think the business model is the most critical element. It's really not about technology. And in that vein, I'll mention one thing. I was on a call with a partner in the Democratic Republic of Congo the other day, Nigeria. We were talking about 4G, 5G, 6G, and he was talking about how the future there is 4G. Just something to keep in mind is, we in the innovation world and the academic world talk about 6G. People in many parts of Africa are struggling to get 2G connectivity, and 4G would be a complete game changer for them. So just some of the elements that seem mundane, but are really critical to the work that we do is site identification and broadband mapping, which is a project that is very important to the Marconi Society as well, at least in the US, but this is a worldwide issue. Where do you get the data? Census data is old. How do you know where people have connectivity, where they don't? And how do you match that up with what the likelihood is that people are going to pay for that connectivity? So ARPU, the average revenue per user, is critical. I would say as important as anything else is spectrum availability. Of course, you can go in with wireless, with Wi-Fi based bands, but coverage is lower. And if you're trying to reach places in Nigeria where there's not lack of connectivity, some of these are tens of millions of people that live in suburban areas that are more than 40 kilometers away from fiber. So it's not just ultra rural villages. There are many areas that have no connectivity that look to us like they're more urban. And without that spectrum availability to get additional coverage, it's very difficult for new operators to enter markets. And the traditional operators tend not to want to share that regional spectrum that they own. It's not that even that they're using it, they prefer to put their efforts and focus into their more urban areas. So costs are really critical. And the costs include things like I mentioned, satellite bandwidth economics, low cost per megabit per second. The cell architecture has to be very simple. We're not talking about macro cells that you'll see in the cities with massive MIMO antennas. We're talking about integrated solutions, in many cases, single antenna omni solutions. Low cost power consumption in Africa is absolutely critical. Solar is one of the most expensive components of an entire cell site. So that's a really critical area as well. And that's not true all over the world. We don't see those requirements in Mexico or South America. Tower complexity. And then of course, the last one is you can do all the right things, but if devices are not available in the bands that you need them, then you have to find some way to subsidize those or lease them or make them available to people that really cannot afford any significant expenses. So that is it for my presentation. I'll stop sharing and wait for some Q&A. Thanks.
Thank you very much, Anton, for your very interesting presentation and for bringing to us the faces of the people that need this connectivity. This is very important. So next presentation is going to be done by Ruth Pritchard-Kelly. Again, Ruth, you may start sharing while I introduce you. So Ruth is an expert on satellite regulatory policy with over 30 years of experience. She's currently the senior advisor for regulatory affairs at OneWeb, and she has also worked at O3B, now CES Networks, and American Mobile Satellite Corporation.
Anna, I appreciate the introduction. Again, I'm the senior advisor for regulatory and space policy for OneWeb, one of the new satellite technologies who's going to be used to complete digital inclusion. So ViaSat talked capably about the GEO satellites, although I believe ViaSat also has a LEO constellation that they are working on. So these technologies are coming to fruition. And I don't think that they are competitive. I think they will complement each other. I think all of the different technologies are going to be needed depending on the specifics of the location. And so let's talk about LEO constellation. So I like this graphic because it's easy to visualize how the different orbits cover the globe, right? So up at geostationary, it's brilliant. A single object, a single satellite covers a third of the globe. It's an incredibly efficient way, especially for point to multi-point broadcast of information, especially one-way information. The issue becomes when you need real-time two-way interactions. Geostationary is a bit far away for many of today's internet applications where you want a live simulation, right? And so the medium Earth and even the low Earth orbits have become more attractive because the demand has risen, and so now it makes the cost, which it is considerable, of putting up a low Earth orbit constellation more affordable. So here again is another visualization of the distance, and I like to point out that the LEOs are no further away from you than a transatlantic fiber cable, right? So the latency truly is 4G quality. For these low Earth orbit satellites, you will not notice that you are going via satellite the way a phone call of years before on a traditional satellite link had a bit of a delay. So that's no longer going to be an objection. That is no longer an issue with the low Earth orbit for your two-way applications. Here's a slide that shows how the LEOs are coming to fruition now because of the sweet spot between the incredible increase in demand, both because of the invention of the internet, but that also happened at the same time as the rise of the personal mobile device, right? This is far more than a telephone, isn't it? This is a connection to everything. And so that demand for that internet service coincides with incredible advances in technologies for rapidly building and constructing satellites, right? They're now on assembly lines. Keep in mind, they used to take a year or more to hand build a single geo satellite, and now SpaceX and OneWeb can build a satellite a day, sometimes 2 or 3, right? And also the launch vehicle costs have come down. Not only are the traditional vehicles expanding their capabilities so that they can launch, for example, 35 or 40 satellites at a time, the way Ariane does for OneWeb, but there are new launchers coming along designed specifically for smaller satellites. And they're able to launch from not just at the equator, but from different areas around the world, bringing the cost of the launch down as well. And so this is just the timing is right. It's not as though the engineers of 60 years ago didn't realize that a lower orbit would be better for a phone call, but it was not affordable. It was absolutely prohibitive until the invention of the internet and the mobile phone. Here's a quick video. There is no audio. This is just of the factory in Florida that is jointly owned by OneWeb and Airbus. Airbus, I think known to everyone, foremost manufacturer of airplanes, was very interested in getting into the cutting edge of assembly line manufacturing of satellites. And that's what we have. And when this factory runs at full, which has been hard, obviously, with the pandemic, 24/7, they can produce 3 of these satellites every day. So, right, that's 90 satellites a month. And it also means that as we move up to a Gen 2 design, we can quickly just swap in the new satellites and launch them within a month or 2. It really is transforming the satellite industry. I think everyone has heard about OneWeb's bankruptcy. I think we may be at the same time the poster child for how COVID destroyed industries and financial markets, and at the same time proved unequivocally the business market sense of needing remote connectivity, right? And so within months of the world basically shutting down, and everyone realized they needed to sit at a computer far away from other people and have a good connection just to do their job or get an education or information from the government about what's going on with vaccinations. That meant that within months of declaring bankruptcy, because our financing pulled out, new investors came in, backed by the UK government and Bharti Airtel, one of the largest mobile operators in India and Africa. And since then, Eutelsat, the European satellite conglomerate, and Hanwha, a Korean aerospace manufacturer, have also joined. So OneWeb is a truly global solution. Again, we're launching monthly We already have half of our first gen in orbit, and we have the next launch scheduled for October 14th, and we launch almost every month another 34 or 36 satellites. It's very exciting. By the end of 21, we will have enough satellites in space to have 24/7 coverage north of 50 degrees. And by the end of 22, our full constellation will be in space, meaning that there will be coverage literally on every spot of the globe, including at sea and in the air. Again, just a quick rundown of our statistics. Our first constellation has 12 planes. They orbit at the poles with roughly 49 satellites per plane, and we'll have spares. We're at 1,200 kilometers. Low latency, again, that means a very little delay as the signal goes from space to Earth and back again. Very high throughput. That means it's broadband. It's what you can do internet with. You can stream anything. Quick manufacture and quick launch. We are pretty excited. Excuse me. So here's a graphic showing that we use the KU band for our user terminals. That's the 12 to 14 gig band, but we use the KA band for our gateway connections. And we've got about 40 gateways spaced evenly around the globe where we drop all of the user links directly into the internet. It's very interesting to me and super important for regulators around the world to hear that every single one of these LEO constellations uses the KA band at a minimum for its gateways, but some of the operators are also using the KA band for their user links. So an encroachment into the 28 gigahertz by a terrestrial service will significantly hamper the ability of this LEO satellite technology to reach the unconnected. And I think everyone pretty much agrees that most of the terrestrial services are in the population centers, right? That's their best service. They're never going to be built out. It's economically prohibitive, if not physically prohibitive, because it's an island or in a jungle or a forest to have a terrestrial link. So you've got to protect the 28 gig KA band for the satellites. And ViaSat at GEO is also using KA. So it's not just the LEOs. It is all of these fixed satellite services. I think that this is a quick video that is not running. Oh, there we go. The green signal shows a gateway connecting to the satellite. The long rectangular bands are our user links. And what happens is before the green gateway loses connectivity, the yellow gateway picks up the link. So there is never a drop in the customer link, right? And then the green gateway will drop off and track back to the next satellite in the same plane, right? And now you see the hot pink, the fuchsia gateway picking up. And here we have a whole single plane with the gateways evenly spaced so that those users never lose connectivity. They get passed from satellite to satellite without any awareness that there has been such a handover. Here is a picture of the global constellation covering every spot on the globe. Here's just an example of some of our gateway stations. They're all over the world in all kinds of climates. We prefer a drier climate, but when it's cold and windy, you've got to put a dome over it. And if it is too close to a rainy region, we often have gateways that are closer so that you can hand off to avoid any rain propagation interference. And we've got about 10 of them built already. And most of the others under contract and ready to be built in the next 6 to 12 months. Here's a slide showing our user terminal. So on the left is a traditional parabolic antenna. You need two of them. We call it a dual parabolic, and there's a little dome. Again, if you're at sea or in a windy or particularly cold region, you would need a dome over your little parabolics. And those can be stuck anywhere on the ground or a large building. They're not desirable for a large ship, let alone a plane, because of the weight, right? And even most residences would rather have something small. And that's why moving to the center, all of the LEOs, all of our R&D is focused on these flat panel, electronically steerable, what we call the pizza box, right? A single unit that does not have mechanical tracking in it. And on the far right, the aeronautical ones in particular must be feather light, so light, right? And so we're really working on the right materials to make sure that we have the lightest possible antennas for our aeronautical customers. And speaking of aeronautical, we do like to point out why it might be desirable for many of the airplane routes to use a low Earth orbit constellation as opposed to one at the equator. And that is because the line of sight, right? So if you picture our satellites, they're circling the poles like the lines of longitude on your globe, which means that instead of an airplane pointing its antenna down toward the equator, if the airplane is, say, in the North Atlantic, as many of them are, say, from Europe to New York, it's just pointing straight up. There's no degradation in the elevation angle. There's nothing between it and the satellite. You get an incredible connection all the time. And honestly, that is for the North American or for the Africa to South American routes, right? So when you're not in close proximity to the equator. And again, another visual just reminding people of the many different places where you can put these antennas, basically everywhere. You can install a pole in the middle of nowhere, say along the Trans-Siberian Highway, or if there is no pole, you can add a pole. And then with Wi-Fi, you've connected an entire community on ships or smaller boats, on the side of a building, a community center, a home, planes, military government uses, or offices, right? I mean, this is a way for the world to get a connection, to get an education, to do a job, to get information even about, as I said, COVID vaccines. Where is the potable water? What is the right way to fertilize my field? So all kinds of government information can be shared with its population once we can connect the unconnected. There's my email if anyone would like to get in touch directly. Anna and Samantha, thank you so much for the invitation to this seminar.
Thank you so much, Ruth, for a very interesting and very informative presentation. I think we have many students also in the audience, and I think it's been very nice for them to understand how all these systems work. So our next presentation comes from Thomas Choi, and he's here. But good night, Thomas. It's very late where Thomas is, so he preferred to have a pre-recorded presentation that I am going to show, but he's here for sure to answer any questions. So Thomas Choi is the founder and chairman of Curvanet, which is a fixed wireless access company to offer rural broadband. And he's also the founder and executive chairman of Airspace Internet Exchange Limited. He was the founder and CEO of ABS, a global satellite operator. And he also was the founder and CEO of Speedcast, a global service provider. So he has experience all along the topics of our panel today. I'm going to start again sharing my screen. And let me know in case there is any problem, but in principle.
Founder and chairman of Curvanet. I'd like to thank the Marconi Society for inviting me to speak in this panel. I'd like to talk to you about the application of LEO broadband services for consumer broadband access and how it compares against fixed wireless access. So I'd like to begin. There's a $100 billion race at LEO, as you may have heard throughout the news as well as the industry press, that many companies like Starlink, OneWeb, Telesat, Amazon, Apple, the country of China, the EU region, and many other companies and countries have announced many, many projects for launching low Earth orbiting satellites for delivering broadband access to consumers. The promise will be ubiquitous coverage of broadband services to everybody in the world. And I think if all these projects are successfully launched, there'll be over 100,000 satellites in space with over minimum 100 terabits to potentially 1 petabits of capacity in orbit. And but I'd like to examine, is the solution really going to solve the problem that we have? Let's begin with this. So I believe there's a $1 trillion market of connecting 3 billion people who do not have internet access. We could extrapolate that by comparing how big the telecom market is today. It's 1.7 trillion, connecting 4 billion people, composed of $1 trillion in mobile communications and 700 billion in fixed wireline access. But if we look at the emerging markets, we can see that there's 1.2 billion people without electricity. And this lack of electricity is resulting in them also not having access to telecommunications, because mobile phone towers and telecom equipment need electricity to operate. And if there's no mains commercial power, then there's going to be no telecom services. So in most of the emerging markets, especially in the rural areas, the availability and affordability of electricity is quite low. So any technology, whether it's LEO or terrestrial, that is trying to address this $1 trillion market has to fix the power problem, I believe. And we'll examine that later in my presentation. So is LEO broadband the solution? If we look at the LEO broadband systems that are being designed today, they're using a $2,000 antenna that's composed of multiple ASICs, RFICs, MMICs, RF front ends, hundreds of devices that consume a lot of electrical power and cost a lot of money to tape out and fabricate. So a $2,000 antenna is being manufactured by SpaceX and being subsidized to $500. But even at a $500 level, the developing mobile subscribers or developing consumers in the rural areas, they can't barely afford to pay $50 for a smartphone. So they will not be able to afford a $500 device. So I think this fails the affordability test of the CPE. And then, as I mentioned, there's these devices are consuming close to 200 watts of electrical power. And commercial power is just not affordable or nor available in these rural areas. And to generate 200 watts of constant RMS power is a substantial amount of investment that you would need in a solar array for a home, which would in itself cost several $1,000s. So I think this is not a solution for rural consumers. And worst of all, on the tariff side, the Starlink service is designed at $99 a month times 12 months, or $1,200 a year. This exceeds the average GDP per capita of many countries in the emerging markets. So whether it's the affordability of the consumer terminal, or the affordability of the tariffs, or the lack of availability of the power, I think LEO broadband will fail this inclusion test. It's not affordable for the emerging markets. So let's look at the US consumer market for LEO broadband satellites to see if it makes sense for them to serve the 10 million households that are not without broadband. The FCC has indicated that at least 10 million households in the US do not have 25 megabit speeds. In order for a LEO constellation to serve the 10 million households with burstable 25 megabits, they would have to have 2.5 megabit per second dedicated speeds, or a total of 25 terabit per second. Now, if the demand was up to 1 gigabit per second, then the then the total amount of capacity you would need on the LEO constellation is 1 petabit per second. Starlink has indicated in their recent filings with the FCC that they plan to launch 40,000 satellites, but we should take a look at their first shell that they're launching, which is 4,400 satellites, to see if it makes economic sense to deliver consumer broadband services. So there are 4,400 satellites. Most experts in the industry state that their satellites are roughly around 650,000, including the launch. So the capex would be roughly around 5 billion. They estimate that about 17 gigabits is available on each satellite. So the total global capacity would be 74.8 terabits per second. But you can't use that all over the people because, more than 75% of the Earth's landmass is covered by water, and less than 15% of the surface area of the Earth has where people are living. So we have to cut the capacity down from 75 terabits to about 10 terabits. And the US also is only occupying 9.8 million square kilometer versus the total global surface area of about 500 million square kilometers. But let's say that we took 20% of the total capacity on Starlink above land, and let's say that was above the US, then the maximum number of subscribers that Starlink could serve in North America or the United States would be 800,000 homes or at 25 megabit per second, or 20,000 homes at 1 gigabit per second. And if we look at the revenue that Starlink can generate, given the fact that they have to subsidize each subscriber $1,500 of the CPE charges, they're really only collecting $57 a month in net revenue. So the total revenue that they would be able to generate is $547 million a year with 800,000 subscribers on the 25 megabit plan, or only $14 million a year on a 1 gigabit plan. So certainly the revenue from the US would not be enough to pay for the replacement capex of this constellation. Now, let's examine it against the world. We already discussed that in the emerging markets, this technology is too costly and really there's no power available to power these terminals. So the emerging markets should not be considered. So if we're looking at the countries around the world where people can really pay $100 per month for broadband, let's say countries that are above $40,000 per year in GDP per capita, then that's only a handful of countries. That would include the US, Canada, a couple of countries in South America, most of Western Europe, a few countries in the Middle East, and a handful of countries in Asia, including Australia, New Zealand, Korea, Japan, Hong Kong, Taiwan, and Singapore. But unfortunately, those countries cannot absorb the amount of capacity that would be needed to serve 4 million households, because they cover less than 10% of the total global landmass. So I think the theoretical revenue, if they got 4 million homes paying net $57 a month, would be 2.7 billion per year. But I believe they're not going to be able to get that many numbers of subscribers because they're just not going to get the density of the bandwidth over the territories where people are. So if the only revenue option available to LEO broadband constellations like Starlink was consumer broadband, I do worry about their longevity. I do believe that they should find some other application except for aside from consumer broadband. I think we also need to contrast how LEO broadband compares against not what's available today, but the next generation fixed wireless access technologies. If we look at that, then it's quite telling, because if we look at the 2 terabits that are available over North America, and if we say that capacity has to be used to serve the 10 million households that are lacking broadband, then where if you take the 2 terabits divided by 10 million households, it only means 200 kilobit per second per household. Or if you did it on a density basis, you took 2 terabits and divided by 9.8 million square kilometers, it's only 200 kilobit per square kilometer. But if you look at the next generation 5G, 6G technologies that are coming down the pipeline, including Curvanet, that's able to do this today, from one tower, we can deliver over 250 gigabit of broadband capacity on a phased array multi-beam basis with a range of more than 10 kilometers. So just by taking 10% of the towers that exist in North America, we can place 7 petabits of capacity, or an average speed of 714 megabit per square kilometer, or 700 megabit dedicated per rural home that do not have broadband access, the 10 million homes. So it's easy to comprehend that the services that will be available next year and beyond will be either by fiber or fixed wireless broadband access in the speed of 1 gigabit per second. And if the consumer in a rural area had a choice between getting 25 megabit speed by satellite or 1 gigabit by fiber or fixed wireless access for the same price, what are they going to choose? They're going to choose the fixed wireless access solution that delivers them 1 gigabit. This is why I worry about the future of LEO broadband constellations, because they have not factored in the emerging technologies that are coming out in the fixed wireless space that is unveiling themselves today, that they will find it very difficult to compete against technologies that will be operating on the towers that already exist, that could reach the homes with the speeds that consumers are expecting, which is 1 gigabit per second. So in conclusion, I think the $100 billion investment in LEO broadband is too expensive, too costly, and too power consuming for the emerging markets where there are 3.2 billion people without internet access. And then in the developed markets like the United States, Western Europe, where people can actually afford to pay $100 a month for broadband, terrestrial technologies and fiber will take 98% of the market. Surely there will be 1 to 2% of the market that towers will not reach, which the LEO systems will be able to serve, as well as, transportable cars, I would say, RVs, maybe shipping container, trucks that are moving shipping containers. Those things will need broadband access, and maybe that will go to LEO broadband. But the consumer who are living in fixed homes, who are able to be served by towers, will all go to fixed wireless access. So LEO broadband systems need a different applications to generate revenue, to pay for their fleet, as well as to make their businesses sustainable. But what's most exciting to me, because I'm working on this as well as the world, should be that soon advanced beamforming long-range wireless access products will be out in the market that is very low cost, low power consuming, and low user terminals, which will be competitive to fiber optic cable in being able to deliver more than 1 gigabit per second to each household. So I feel that just with less than 10% of the towers in the United States, every home that does not have broadband will be served by fixed wireless access of speeds over 1 gigabit per second. Curvanet is introducing a technology this year in the fourth quarter that can achieve these speeds, and we're one of the leaders in this market, and we're very excited for the future. Thank you very much. That concludes my presentation.
Okay, I'm going to stop sharing my screen. Thank you very much again for a very interesting presentation, and thank you for bringing the cost issue to the picture. I'm sure we will talk a lot about it. So our next and last presentation is going to be given by Baris Erkmen. Baris is presently the Free Space Optical Communications Lead at X, formerly Google X. He was Research and Development Manager at Facebook Connectivity Lab. And he was also at Jet Propulsion Laboratory, where he initiated and participated in several programs on classical and quantum optical communications. Thank you, Baris. The floor is yours.
Thank you, Anna. Can I confirm that you can see my slides? Very good.
Yes.
All right. I want to again thank the Marconi Society and Anna and Slim for inviting me to speak at this panel. My name is Baris Erkmen. I'm from Project Tara. I'm the engineering lead on Project Tara at X, the Moonshot Factory. And I'm delighted to be here today to talk about some of our efforts to help bridge the digital divide using wireless optical communications technology. Let's see if I can advance here. All right, every project at X has 3 core pillars. They have each a big problem that they're tackling, a radical solution to that problem, and that is enabled by some breakthrough technology. Self-driving cars for transportation, automated delivery drones for logistics are 2 examples of that. For Project Tara, our big problem is the digital divide and the nearly 4 billion people that do not have access to affordable broadband internet. No matter where you've been living in the world in the last decade, growth in data has been exponential, and all projections into the next decade show that the growth will continue to be exponential at an even accelerating rate. On the other hand, depending on where you've been living in the world in the last decade, your access to fixed broadband internet has been quite varied. There are some countries that have done a good job in rolling out fixed broadband infrastructure and reaching most of their populations, not all, but most of their populations. But there are areas in the world, plenty of areas in the world, where fixed broadband internet infrastructure has been persistently stagnant over the years. And the disparity caused by inequity in access creates inequities in commerce, in education, in healthcare, and collectively it causes what we experience as a digital divide, or the lack of digital inclusion. On Project Tara, our objective is to provide abundant and affordable access to broadband internet for everyone. And when we say abundant, we mean that anyone should be able to consume hundreds of gigabytes a month without experiencing network congestion or slowdown. That's the ideal broadband experience we have in the developed world today. And by affordable, we mean that the cost of consuming a gigabyte of data should be on the order of pennies and not the dollars at which it's today. We all know that fixed infrastructure is slow and expensive to roll out, and so our focus is on the small and flexible footprint that's offered by wireless technologies. And finally, we'd like a solution that is future-proof in capacity so we can keep up with this exponential growth in data. And so we're looking for areas of the spectrum that have a lot of bandwidth, that is uncontested and uncongested, and also has a reasonable cost of access. When you write all these requirements down and you scour the electromagnetic spectrum to think about where you could operate, optical frequencies do come across as one of the strong contenders. And for this reason, for the past 5 years on Project Tara, we've been focused on making the necessary technical innovations to be able to bring wireless optical communications to the marketplace at the necessary robustness, cost, and scale for it to be a solution to bridging the digital divide. So here's a picture of our current generation terminal. We're calling it the V1 system, installed on 2 towers. I believe it's in Nigeria, but don't quote me on that. It offers a bidirectional 20 gigabits per second full duplex connectivity. You can install it up to ranges all the way to 20 kilometers. There is a trade-off between availability and range, and I'll talk about that in a second. It operates in the near infrared wavelength, 1550 nanometers. It weighs 13 kilograms so that a single person can put it on a tower and install it all by themselves. It consumes 40 watts, so it's less than an incandescent light bulb. And it's a Class 1M iSafe system, which allows you to operate in publicly accessible spaces with minimum restrictions. I'm happy to report that all the build, qualification, packing, shipping is handled by one of our contract manufacturing partners. They built in excess of 250 links to date and are continuing to do so at a steady pace. We have about 50 links out in the world, either carrying live traffic in partner networks or participating in pilot trials. We have another 80 that are staged in customer premises, but we haven't had the ability to deploy or operate them yet. The pandemic has certainly slowed down our ability to do so, but we are continuing to work on that. And the rest of our terminals are in various stages of their towards their final destination to be brought up. All right, when we talk about wireless optical communications, we do have to talk about availability, because in cases where the visibility is poor, heavy fog, heavy rain, lasers also scatter pretty heavily, and you can experience an outage on your link. So what we're showing here is a plot of all of our links that are out in the field that we're measuring availability for. The x-axis is the range at which the link is operating at, and the y-axis is the measured availability since 2019 November of 2019, all the way through the middle of September in 2021. Every dot on this plot is a link that's been operating. The asterisk 3 dots on the very right side in long range is there because the links had to be upgraded at the beginning of 2021, which reset the availability clock. So that's the only exception there. The solid line that we're showing is the availability you would expect from our terminals if the visibility statistics were that of the US average. What is somewhat surprising but interesting is that even though none of these links are in the US at the moment, their average behavior is pretty well represented by that trend line, the solid line. There is a spread around that mean, of course, and that is because local visibility statistics vary. We are able to use local visibility statistics to predict the performance of each of these links precisely. There are some outliers. I don't want to call those out. Then those are experiencing quite outside the norm of visibility statistics. The red dot, for example, that's around the 75% availability mark is up in the Himalayas. And I can say with a straight face that that has definitely put our links to the test. And so there are certain places in the world that certainly do not have favorable weather, but there are many parts of the world and many parts of them that do require broadband access where this technology is a viable technology. As I transition to some of the use cases for wireless optical communications, let me start with one of the announcements we made a few weeks ago. It turns out that the Congo River, one of the fastest flowing and deepest rivers in the world, is a physical manifestation of the digital divide between the two cities on its two banks. Brazzaville and Kinshasa are two cities on the two banks of the Congo River that receive their internet from two separate landing stations that are 400 kilometers apart, because it is too challenging or too expensive to connect these two cities directly with a fiber that goes underneath the Congo River. As a result of that, Kinshasa's internet cost is 5 times more than that of Brazzaville. Together with our partner Liquid Intelligent Technologies, we decided to cross that digital divide over the river using wireless optical communications. The link we set up is a 4.8 kilometer link. It is offering 20 gigabits per second bidirectional full duplex connectivity between those two cities, as far as I know, for the first time. In the first 20 days of our operation, we've served 700 terabytes, and since then, the throughput has been steady, so that number has certainly grown. The availability is phenomenal. We're quite happy with it. It's north of 3 nines availability and pushing 4 nines at 99.96%, measured since the end of May, all the way out to the middle of September. There are also other use cases for wireless optical communications, even though it offers less than perfect availability. First, there are many places in the world where the fiber optic infrastructure consists of linear pole fiber, and you can complete those into rings and provide network resiliency by weaving the last piece with wireless optical communication links, or maybe a relay of them. Perhaps equally importantly, you can reach the communities that are only a few kilometers away from the fiber optic backbone, but do not have access to broadband internet today, and bring them online to the broadband infrastructure as well. And there are many cities, even in the developed countries, in the US included, where communities only a few kilometers away from the fiber optic backbone do not have access to broadband internet because there is no cost-effective way of bringing that broadband capacity into the community. You can also think of wireless optical communications in a hybrid topology. Aerial fiber has about 97, 99% availability in many places and has failure modes or outage modes that are largely uncorrelated with what would take out a wireless optical communication link. And so by deploying those in parallel, you can get with two 97% available technologies, 3 nines availability, 99.9% or north of that. You can also help relieve congestion on a microwave link 97 to 99% of the time, only to fall back to that RF link the 1 to 3% of the time where weather does not permit you to offer high speed over the wireless optical link. And of course, as I showed in the previous slide, there are many natural barriers that manifest digital divide as well that you can cross with wireless optical communications links as well. All right, we are very excited about our V1 technology, and we look forward to increasing its impact in the world and helping to contribute to bridging the digital divide. But our eyes and minds are squarely on the future of connectivity and the future of wireless optical communications technology. We believe that there is a significant cost and scale opportunity by integrating the optics and photonics of the current generation state-of-the-art systems onto photonic chips. We also know that pointing and tracking of the laser beams is a critical piece of robust optical communication links, and having non-mechanical mechanisms of controlling that beam, we believe, is a really important enabling technology for the future. We also believe that the future networks will be more distributed and more mesh-like in their topology. That'll offer some natural resilience to part of the network going down from, let's say, weather-related outages, and having ability for real-time dynamic routing that is aware of the network status is another important piece of the future of connectivity from our perspective. And finally, the future of connectivity will have many different access technologies, from wireless RF to wireless optical to wireline technologies. And from a consumer's perspective, the connectivity, we believe, should be seamless and uninterrupted, regardless of the physical media used to connect. And therefore, having seamless integration of different physical layers with very different channel statistics, we believe, is a very important piece of the future of connectivity. We're active in all of these areas. We're hoping that some of the innovations we're able to make in this space will come out in future products and projects to further improve our connectivity future. And finally, if I may say so, if you share our passion for our mission or our vision for the future of wireless optical communications, or you have a use case where our V1 technology could be useful and beneficial to helping to bridge the digital divide, we'd be eager to collaborate and partner with you. And so depending on the nature of your interest, I have some emails up here. Please feel free to reach out. We'd be excited to talk to you. And I'll thank you for your attention and look forward to the discussion session.
Thank you very much, Baris. Very interesting and very exciting technology. It's amazing that you already have deployments in very difficult places. So now it is the time for questions. I've seen there are a few in the chat. So I have some, but I'm going to just go ahead and ask one question that I will kindly ask each of you to answer, probably in the order that you appeared, and then we will see what questions we have in the chat. So my question is, regarding the technology you are using to connect the unconnected, what are the main obstacles or challenges that you are facing, be them technological or non-technological ones? So if you like, we can first start by Anton and we go on the same order.
That's a multi-dimensional answer, I think. There's regulatory issues. There's some technical, and there's a lot of cost. And the regulatory includes spectrum. I think first of all, let me say that, in response to some of the comments Tom made, and let's separate higher ARPU environments like the US, where you could afford a single CPE on a home, perhaps at a $60, $80, $100 ARPU, versus some of the countries we spoke about, as Baris pointed out, DRC and others like that, where maybe it's $1.50 or $3 or $4. And nobody would really expect that you're going to have a single user terminal, satellite or other, on the side of a home. Okay, so it's really all about cost-effective, multiple access technologies. And there's really two options: unlicensed or licensed. Unlicensed has some limitations. If you want to do licensed and try to get lower spectrum, greater penetration, greater coverage, you have to acquire spectrum. I would say that is the single most challenging aspect to cellular rollouts for non-incumbents. And the problem is the incumbents are not that interested in these areas. And to be honest, why should they be? They've got massive population centers where they get a much bigger bang for their buck in spending money on expanding their macro cells. So why should they be interested in these rural areas? So that leaves it to people like us, OneWeb and others doing satellite or microwave, as Tom pointed out. But to be honest, in many of these areas, there is no microwave. You know, maybe you could do it with 5 microwave hops, but you've lost all your capacity if you're trying to do that many hops. So we're talking about billions of people that cannot get coverage in areas that cannot even be reached by microwave. So it's really about cost, and spectrum, I think, rises to the front. Most countries, no countries have CBRS like we have in the US. CBRS is a great opportunity for rural US new non-incumbent providers to come and make a difference where there's no interest in providing connectivity. So I would say spectrum is key. I think many of the other pieces can be solved, as I said, with building a solution that's not macro oriented, going with some of the newer vendors that provide low cost solutions, in-country manufacturing of masts and things like that. But we can come back to it if there's more questions. I don't want to take too much time.
Okay, thank you. Ruth?
Thanks, Anna. Yes, that's a wide question. So adding on to Anton, I think on the regulatory side, you know, when you buy your phone, you don't need a license. So I think regulators need to get to that point with satellite terminals. What does it take where the user doesn't have to worry that the terminal has been licensed, or existing satellite television, right? For at least in the United States, you can buy satellite TV. You don't need to go to the FCC for the license for that dish on your roof. And so the regulators need to be thinking that that's their goal. The goal is the end user doesn't need to worry about whether its terminal, whatever size it is licensed. So we have some ways to go before we can get there. But obviously we did get there with mobile phones and with satellite delivered television and geostationary satellite delivered internet as well. I believe you don't need a license for that dish. So let's get there. Technologically, those dishes for the LEOs, they're not there yet. Wow, I encourage every inventor in the world, please, to work on those flat panels, on those pizza boxes. Let's get them small, let's get them working. And as Tom said, how about things that are powered by solar? How about powered by bicycle, right? Electricity is not available everywhere where you need these. And so that's an opportunity and an obstacle.
Thank you. And yeah, many researchers are probably in the audience, so it is very good that they know what are the main needs. Tom, what is your view?
Yeah. First of all, let me apologize for not giving the presentation live. It's like 1 a.m. for me, and you saw my presentation was really complicated with a lot of figures. So I would have surely messed it up, and I tried to attempt it. So I think, you know, as Ana Garcia mentioned, most of my career has been in satellite communications, especially from GEO. And I did not make any comments on GEO, but I believe delivering rural broadband connectivity by GEO high throughput satellites could be one of the very good solutions for rural broadband connectivity. You know, I'm speaking on behalf of Anton, but one of the reasons is that a GEO terminal is very low power consumption. It doesn't consume. It probably is about the 10% the power level of a LEO terminal today, and then the licensing regimes for GEO satellites are very understandable, and the service availability is going to be dramatically higher on a GEO system, because the LEO systems constantly are moving, ducking behind trees and mountains, buildings, things that I called earth fade. So I certainly do believe that for a pure consumer play, that a GEO system where the terminal cost can be very, very low cost and low power could have a role to play in emerging markets. So, but to specifically answer your question, for our technology, we have both, as Anton mentioned, we have both unlicensed and licensed products. everything that, well, what I did was I took satellite beamforming technology, shrank it down into a little tiny box that consumes very little power, and we needed to put it up on a vertical asset. So we need to work with tower companies or telecom operators who have towers. And many of the experiences of the telecom operators is that if they use unlicensed frequency, they have met with so much interference because the antenna technologies are so poor. They're basically omni antennas, low cost, very cheap. You have low range, but then if your neighbor is using the same frequency, you get interfered with. But our technology is beamforming, so we actually have a massive side lobe suppression. We can operate our unlicensed product in the middle of Jakarta, where we've done tests, 20 megahertz of spectrum. We were able to send signals multi-kilometers away, 100 to 200 megabits, depending on the line of sight. And that's with thousands of Wi-Fi interference. So even though our technology is great, it's working, we have to get through the barrier of the mentality of the telco operators who have these towers, who are initially facing us with a lot of doubt. So going from country to country, operator to operator, doing demos and trials, that's a monumental effort because we want to try to be out there in the world. And so that, to me, just diffusing that innovation through the market is a big challenge. But fortunately for us, we work with an anchor customer, Globe Telecom in the Philippines. They're a unit of Singtel, and Singtel also owns the shareholder of OneWeb, Bharti Airtel. So we worked with them for about 18 months, and they did extensive testing of our system. And they've decided to do a nationwide rollout. I mean, they tested our system compared to all the top wireless providers, including Huawei, Ericsson, Nokia, all the, Cambium, all these other companies. Nobody else had a product as capable as what we had. So they chose to work with us. So we're going to start there and go, operator to operator, region to region. But for us, convincing the telcos is a long drawn process because they have a lot of, previous installed biases and opinions.
Thank you very much, and no need to apologize. It is us who are very thankful for you being here at this time at night. Thanks a lot. And then, Baris, what is your view?
Thanks, Anna. It is a difficult question, and I've had the benefit of being able to think about it a little bit while our other panelists were answering. I think at the highest level, what I'll say is, at least the way that we think about it, the ideal internet experience would be a combination of having a lot of capacity all the way to the edge. And that is a combination of different technologies. It's not always a single solution, but being able to bring that capacity all the way to the edge and being able to push down how much it costs for every bit that flows through that pipe. There are technology innovations necessary for that. Optical is part of that ecosystem. There are other non-optical solutions that can be part of that ecosystem. They can be satellite-based, they can be terrestrial. I think there are different combinations that work for different markets. Even if you look at the first 4 billion that are connected, it's not like there's one solution that fits all. It's very different depending on the market. Same thing applies, I think, to the second 4 billion. But the key is to deliver high capacity all the way to the edge at a price where the cost of each bit is very low. There's technology innovation, as I said, and that's challenging. There's also business model challenges, I think, because many of the ISPs and other service providers don't necessarily monetize on a dollar per bit basis. And that can cause challenge. Even if you deliver a very low dollar per bit solution, that's challenging if the monetization strategy doesn't match that. So there are other business related challenges that require also technology innovations to help assist with that transition. And of course, there are policy related challenges as well, which I won't get into because it's outside of my area of expertise, and there are far better experts on this panel.
Thanks a lot. we have a lot of questions in the chat, but first I wanted to give the opportunity to the panelists because I think maybe there are some questions or answers among some of you. For example, Ruth, I think maybe you wanted to say something. Please go ahead, we have time.
Thanks so much, Anna. And I think, you know, Tom and I have had a quick chat on this. So Tom's presentation was about the lack of affordability of these LEO systems. And of course, he's talking about individuals not being able to afford the system. And OneWeb specifically is not targeting individuals, at least not in the beginning. Our strategy is that we are the extension to the existing mobile network operators, right? So many nations have universal service requirements. They want their population covered wherever it is, right? And the idea is that the technology doesn't really currently exist, or if it does, it's not affordable. However, the LEO constellation, the coverage is there. Why build out a new tower or anything new terrestrial at all if you can just install a terminal and with Wi-Fi connect an entire community? And so for the mobile network operators, the LEO constellations are incredibly affordable, the most efficient way, the most successful way for them to finally cover all of their country's population. And so, Anna, do you want me to just run down some of the other questions that came through? Right. So someone asked about ISL, so inter-satellite links, which are brilliant. And I think not only do we need to have inter-constellation links, but eventually I think we are going to need links between different constellations and different orbits as well, right? Because once again, the end user does not care about the path. Look at the internet, right? And so they're coming, but when OneWeb's first generation was designed and started building, broadband ISLs were not there. The technology was not there, and it is obviously being discussed for generation 2. It will make the connection more efficient. And importantly, to many nations, it can guarantee that the signal from one of their citizens or their territory also lands in their territory. It does not come down in a foreign nation. And so that is of interest to many nations. So they're coming, but they're not there yet because the technology really wasn't developed 3 years ago when we started building our satellites. Space debris, light pollution. Yeah, yes, there are concerns. So it's a big issue, right? The issue is not accidents between operational satellites. They're operational. You can move them. There's a huge worldwide global network of operators and governments paying attention. So we know if an incident is a conjunction is coming our way, and we hop out of the way. That's not the issue. The issue is the small pieces of debris that people can't track. If it hits a live satellite, that's a problem. No one wants collisions. We lose money, right? This is not the industry's goal. We are paying close attention. Light pollution was unexpected. I will admit we were not paying attention to that, but we are now. You can be sure nobody wants to ruin the dark skies, and so massive conversations going on with the astronomy community and all of the constellations. And I will just say, you know, yeah, SpaceX has said 42,000 satellites, but I mean, that's just like what they thought, maybe. Nobody thinks they're going to launch that many. OneWeb is certainly not going to launch anywhere near that many. What happens with Gen 2 is our satellites will become more powerful. We won't need more of them. We'll just have better satellites replacing the ones that are there. So it's super unlikely we're ever going to have that many satellites to obliterate the sky. Question about why you need mega constellations when Iridium only needed 66. Good for Iridium, they were narrowband, right? They were voice. That's not what people are doing today. People need broadband, and we're trying to do it with as few satellites as possible. Obviously, the MEOs thought they could do it with only about 8 or 12, right? They could cover most of the population with 8 or 12. That was pretty good, but it's not all of the population, and it's not 4G quality. Orbital debris, you answered that. Okay, I think I'm done. Next.
Thank you very much, Ruth. Thank you. Thanks a lot. There are a few questions in the chat for Anton about the cost. So how do you ensure the economics work for rural and remote sites? And there are several questions about that. It is clearly something people are worried about, So please, Anton, what is your view about it?
Well, like I said, I think I showed some of the elements in my last few slides of my presentation. So it's really, again, it's multidimensional, the issue here. Spectrum is as much at the top of the list as anything else. Can you get access to low-cost spectrum? Can you partner with operators that aren't using that spectrum in some sort of rev share model? Can you acquire the spectrum? Can you seek to influence regulators so they adopt these tiered shared spectrum models like CBRS? You know, these things take a long time. Or you fall back on Wi-Fi, and Wi-Fi has its own set of coverage issues, and you have to ask yourself, what are you trying to achieve? Are you trying to achieve full penetration in a home like you have in you know, like we desire, what we're used to in the US or Western worlds, whole home coverage? That's not really reasonable in these locations where people are just paying a few dollars a month. So maybe it's sufficient, and also the homes are smaller. So what we've seen is that perhaps it's sufficient to reach the front door, which gets you to the main living area. You don't have to reach every area in the house. So you don't need Wi-Fi extenders. So Wi-Fi may be sufficient. The other piece is you can't look at multi-sector solutions like you would expect in denser areas. You're talking 20 watt, 10 watt Omni solutions, leveraging what's being done in some of the open standards efforts. Facebook, for example, has an open source core that they've been pushing, open source packet core. So I think prices are coming down. The RAN itself, if you're looking to deploy cellular, is no longer anywhere close to the most expensive component. And like I alluded to previously, in areas that don't have a solid power grid, it's the solar piece. Solar can to support a 300 plus watt terminal with LTE, it could easily be $10,000, $15,000 just for solar. So what are you really trying to do? You're trying to provide coverage that's continuous, or are you willing to accept a 2% outage of sunlight? And then can you reduce the power in the devices? So the number of companies that are focused specifically on rural areas, LTE, 2G, 3G, 4G companies that are focused really heavily on power, controlling the power. Back off. If there's a power outage, you don't have the sun for a few days, you can't charge your batteries, go down to 2G, or go down to 3G, so you're using less power. So I think it's all of these different elements. And then there was a question about the smartphones themselves. That's a huge issue, especially in a band that is not supported, maybe a newer band by most phones. So what's the penetration of devices has to be looked at very carefully. And are there companies that can provide leasing solutions? Otherwise, you have to fall back on Wi-Fi, which most phones will do.
Yeah. So we have time for just one last question, and then
I have a question for Baris.
There is a question for Tom.
Yeah.
About would it make more sense to do LEO broadband operation to operate as wholesale providers? I think you already read the question. So what is your view about that?
Sorry, what was the question? I was just turning on the microphone.
Would it make more sense, more economic sense for LEO broadband operators to operate as wholesale providers, focusing on ISP as customers instead of just an expensive consumer broadband solution? This is similar to something Ruth already mentioned.
Yeah. I would highly recommend that strategy, that a LEO operator tries to serve a, let's say, high-value segment of the bandwidth equation, especially for enterprises. Enterprises actually who are running cloud applications, sometimes many of their applications will not work over geo, so they need a lower latency. So you could imagine a telco in a rural area or even a suburban area. They can have a fiber optic backhaul or a microwave backhaul with a geo backup, and then they can augment that site with a LEO antenna, and then they're able to offer higher value services, especially for cloud computing. Maybe this is not a segment that the LEO providers are really looking at, but I think integrating enterprises to clouds would be a significant opportunity for LEO constellations. And I would guess that Amazon's LEO system is probably aiming towards that application. So either providing a service directly to enterprises, doing cloud applications, or providing a high value bandwidth segment to telcos for higher, lower latency, higher value traffic is probably where they should be the most competitive, instead of trying to be the lowest cost dollar bit to the low income user in the middle of nowhere who will not be able to afford it.
Thank you. Before we wrap up, Baris, would you like to say anything? We don't have more time for questions, but some remarks.
Thank you, Anna. I don't have anything that I can necessarily add to the satellite discussion. I'll repeat to say that I don't think there's a one-size-fits-all solution for the 4 billion that can't afford broadband today. And so I think we should be thinking of multiple technologies, multiple approaches, and in different market segments, you're going to find different players take the lead because it fits the constraints around that local area. So in any case, I'm excited to see what's happening in the satellite world. I'm excited to see what's happening in the terrestrial world, and a lot of technology innovation matched with policy and business innovations. I look forward to where the future is going to take us.
Thank you. Yeah, I'm also excited to see how many advanced technologies can be playing together to fill this gap. And we've seen there is opportunity for all of them in particular scenarios. And well, we've talked about the cost, but it seems there are ways to make a business model profitable by approaching not only the unconnected, but maybe some other market spaces. We've talked a bit about technology challenges, about the need for spectrum that always comes for sure into play. And I think it's time to thank you, all of you, for some very insightful presentations and discussion. Thank the audience, because this is not very interactive, but they were as interactive as it could be, and they asked many questions. And back to Samantha to say goodbye to everybody. Thanks a lot.
Thank you so much, Anna. And thanks to all of our panelists for that really, truly excellent session. And of course, a thanks to the Internet Society for being our streaming partner and enabling so many others to join us from around the world today. I always am learning so much from these sessions. Anton, thanks for bringing to attention, the idea that we really need to be thinking about the business model, not just the technology. To Ruth for talking about the difference between the LEO, the MEO, and the GEO satellites and how they function differently with regard to performance. Thomas, you talked to us about how many people are without electricity, that really 1 out of 3 people lacking internet also don't have electricity. So that's another barrier that we really need to think about when we're trying to connect the unconnected. And of course, Baris, you talking about your the wireless optical communications and what's on the horizon is always so interesting. So thank you all for everybody. For those of you who are joining us via streaming, if you liked today's content, I encourage you to register for the event at marconisociety.org/decade. So if you haven't done so, go ahead and do that today. To keep the conversation going, we're going to be we'll have another session tomorrow. So we hope to see you again then. Thank you so much for your time. See you on the web.